Okay, I think we're firmly at time. So what do you think, Ross? Let's get started.
Absolutely. Let's go.
Well, welcome to the first official Plans Working Group meeting here at IETF 125. Wherever you are, obviously this session is being recorded, not just for the Meet Echo stuff that allows us to bring me to you over this video screen, but also this will be posted on things like YouTube, I believe. In the IETF, we have this thing that's called the note well, which means that you need to take note of this really well, which means that you agree by being here that you're following the IETF guidelines for professional conduct, i.e. be nice to people. We are talking about people's ideas, not people's identities of person. And if there is someone that is not behaving accordingly, please reach out to the chairs or the ombuds team. There's the rules around IPR. So if there's anything that's covered by a patent or a patent application that is either by you or by your employer or anyone that's paying you to be here, then you need to disclose that or keep your mouth shut, both on the mailing list and in this meeting. That is, I think, the most important stuff that we need to say here. Of course, there's a full version of this that you can find by scanning this QR code. Always useful is that if you're in person, please sign into the data tracker. There's a bunch of QR codes posted around the room. And what this helps us do is that when there's a next meeting in the next location, they will make sure that they don't put us in a broom closet because only 5 of you said that they were present. And then the scheduling team says, oh, plans is only 5 people, so we can put them in the broom closet. So please sign in. You can also use that to join the queue when you want to ask questions. If you are not in the queue, we'll not let you ask a question. Remote participants similarly use the tool that you're viewing this on right now when you want to send voice or video, but please get in the queue first. And for those that will be presenting, we can give you control over the slides via the same tool. And for everyone, please, although for the people that are remote, their names will be nicely written down in the system. It's still nice to state your name so that the people taking notes and also Eckerbot will have that context. There's a bunch of links, but I think that's more or less useful for after the fact. Yeah, we're underway. We have a charter now. There was an extensive discussion on that on the mailing list. Unfortunately, some planned puns had to be trimmed, but that is the nature of things. Unfortunately, sometimes you have to let business come in front of fun. But we will have committed to delivering 2 documents per our charter. One of this is more or less the actual Merkle Tree certificates system draft, but in front of that actually is a deliverable that describes the architecture, etc., for these logs that are based on transparency and stuff like that. That work has not really started yet, but the first discussions on how to spin that out of the existing drafts have been happening on the mailing list. So yeah, that's, I think, the most important thing to say on the charter. For the other thing is that the draft that was sort of the center of the BOF and everything has now been adopted as an official working item, and thus is now with working group control rather than the authors. So that's also exciting. Anything to add, Russ? Perfect. Moving on, we have the agenda for today. We have this the introduction. Then I'm quickly going to open up start with what the options are, and then very quickly bring up the fact that we have to make a collective decision on how to interact with GitHub. I say collective, but the chairs have a big say in this, a little bit more than the average participant. Then there's a document update on the recently adopted draft by Dave Benjamin. Brandon McMillan has put together some slides on monitoring issues and what we can do with that, maybe improve the draft in some way. Then we'll see some reporting from Chrome and Cloudflare, and Filippo Valsoda has graciously offered to help clarify how MTC can work in varying settings for the PKI. And that's it for this set of slides. So unless anyone has anything for the agenda, for which now is the time to speak up. Going once, going twice. GitHub. Yes, I do want to move to the next deck. So GitHub, there's this draft that was written a number of years ago that has the helpful title of Working Group GitHub Usage Guidance, a set of guidelines for working groups that choose to use GitHub. We rolled into this sort of by default because the authors of the Merkle Tree Certificates draft were using GitHub, but now we're a real boy working group. We need to actually make a decision on this. So there's this nice bit of text that says that working groups, the chairs are responsible for determining how a working group best gets their stuff over the line, and that we should talk to the area directors on how to do this. So we'll definitely be getting in touch with Deb here as well. But more or less, this document, so the RFC lines out 3 different approaches. One of them is just the document lives on GitHub, and GitHub is used for change control. But other than that, any sort of discussion on how do we do this, how do we do that, will be resolved on the mailing list or face-to-face in meetings such as this one, which has the upside of maybe things getting in more people inboxes, but the downside of maybe being a little bit more clunky than other approaches. The issue tracking mode is basically the authors create issues and fix small things on GitHub, but anything substantive must be resolved exclusively on the mailing list. And finally, the issue discussion mode is more or less, you can just do triage of basically anything on GitHub, although it's still very much encouraged to bring substantial discussion points to the mailing list, even if that is just, we're discussing this item here, we have option X and option Y, the discussion is over here on GitHub. That sort of thing would still need to happen. But yeah, those are the options. We have a GitHub organization, so that is where things will end up being. But for now, it's not been set up by the IETF Secretariat yet, so I need to poke them again on this. But once it's set up, that will get like the note well in place and stuff like that. I also think we want those summary emails on things that have happened. Following other working groups, I'm proposing that we do the issue discussion mode. So substantive technical matters will be allowed to be discussed on this GitHub issues. I think that is fine. But of course, this is the time for people to weigh in if they have another opinion about this or support this. And we will be confirming this on the list and the ADs before we actually set things in motion in this way. So, everything clear?
I guess the real question is, does anyone object to this direction? Seeing nothing in the chat and no one getting in. Okay, go ahead, Mike.
Yeah, I like GitHub. GitHub is great. I do think the list gets more attention. It's easier to sign up for a list than it is to sign like if you want to be notified when there's new stuff, it's easier to sign up for the mailing list than it is to sign up for like individual GitHub issue watcher things. So like I mean I love long discussions on GitHub. They thread nicely and blah blah blah, but I do think we need to be coming back to the mailing list to let the mailing list know that a discussion is happening on GitHub so that people who want to be involved can be involved.
Okay, any other concerns? Well, we'll be asking the authors to bring big decision points or summarize those long threads as you described them back to the list.
Yeah, I think that is also part of the trade-off with this is that the chairs of the working group will also need to be watching that this is actually happening. Okay, then next deck, David Benjamin, the first official working group draft update.
Oh boy.
Let me try to give you the slide somehow. I think you need to press a button to request that.
Let me see. Request screen share.
No,
Request
you
slides.
can, all you have to do is next to David Benjamin's name is a little piece of paper with a plus sign in it. If you click that, it'll give him
Oh,
control
yeah.
of the slides.
Excellent. I was looking at his video screen, which had some buttons, but not all buttons.
Many buttons. There are many, many buttons.
For sure. Take it away, David.
All right, let's see how this works. Yeah, so I'm here with a document update and no plant puns whatsoever. And let's see if advancing the slides works. It does. Great. All right, we have a draft. I think I can speak for all the authors that we're really excited to see how far this has grown. So now what? Well, we got to get to work. I have a few topics to go over, most of which you've hopefully all seen on the mailing list, but it seems worth going over them here. There's a draft 02. The only real differences between that and what was adopted are we had a discussion about what to rename the really terrible terms that I started with. And there were a lot of options in discussion, but the option that folks seem to most either prefer or be happy with was to turn full certificate into standalone certificate and signature list into landmark certificate. I've started using these terms and they seem to work pretty well in context, but if I've read folks' opinions wrong, please holler and we can go rename them. And the other change is that there was a thread about putting public key types in the certificate log entry. There wasn't a whole lot of discussion, but everyone who said things either on and off list was in favor, so we have gone ahead and done that. But if you disagree, please holler. All right, now onto the architecture document. We said in the charter we're going to write an architecture document, and then we adopted one jumbo document. So we got to go do something about that. I think other than finding the right way to split the document up, I think this is a good opportunity to clarify the kinds of applications where this work is or isn't applicable, and also sort of where this fits into a broader story around joint transparency. Filippo has a great talk coming up about the first one, so I'm just going to talk about the second one. And for that, I'm going to go on a whirlwind summary of what has happened with CT, since that has caused a bit of confusion from talking to folks. So CT started with RFC 6962. I don't think we knew it at the time, but it actually has turned out to be two fairly independent suites of protocols. You've got the sort of structure of the log, the format of the log entries, and the log artifacts that go into X-Farm certs or alongside them, how you use them in a protocol like TLS or something else. This sort of impacts your day-to-day like a protocol's day-to-day interaction with CT. And then you've got the stuff that happens asynchronously in the background, how monitors see the log, any kind of auditing schemes the client might do asynchronously and things like that. And these two suites turn out to be fairly independent. The log artifacts don't really care how the log is being served. It's just we kind of hope it's available in the background somehow, but it's not going to impact directly using it. And conversely, the serving stack doesn't care too much about the details of the log application. A lot of the sort of stuff that you do around monitoring and such is pretty like it doesn't even care what the format of the entry is. It just needs to like be able to process them in some way. And a lot of CT evolution has kind of reflected this split, with the exception of this first step, where we did an update of 6962 to 9162, and it didn't really get deployed in practice. It turned out the kinds of problems that we were trying to solve in 9162 and the ones that were interesting for the ecosystem ended up diverging. So, well. Then the next thing that happened was the so-called static CT API, and this replaced the sort of log interface with a different API that is more scalable and low cost than 6962 or 9162. Structurally, 9162 and 6962 asked the log server to dynamically construct all these proofs, which made them not very friendly for things like caches and all kinds of stuff. And this new one is a bunch of immutable cacheable tiles, which works a lot better with like folk server architectures. This is part of this like whole suite of like T-log work that gives you not just sort of serving APIs, but also stuff for like mirroring and witnessing the logs and all kinds of cool stuff that is happening there. And the nice thing is that we were able to do that without changing the core part of 6962 that protocols actually interact with. Because again, the protocol parts don't really care how they're being like how the log is being served, anything that happens asynchronously behind the scenes. And the sort of T-log suite of stuff is independent of what the log application is. In fact, there's a couple of different log applications that all use the same infrastructure. I think the Go module database is one of them, and Philippe probably knows of all the other ones. I'm not quite as plugged into that. So this was a nice sort of like artifact of doing this split, that one side could sort of be evolved while keeping 6962 unchanged and without having to cycle the ecosystem. Well, so if we change the right half with static CT API, Merkle True Certs is changing the left half. We improved the log entries to scale with post-quantum better. We changed the way that the log artifacts are used in certificates in this interesting way with cosigners. That structure was actually inspired by some of the stuff in T-log, but it's not directly using it. It's sort of intended to be like compatible with it, but you don't have to use T-log if you want to use Merkle True Certs. So it's sort of like a standalone thing on its own. But if you want to build a sort of like within the context of a larger system that wants to use all of this stuff, like you probably do care about either T-log itself or something in that shape. And so the proposal is the architecture draft probably wants to give sort of this like rough overview of what's going on, kind of non-normative overview of like the kinds of things that are available, and say like, okay, so this is where this work fits in. You can use it with this stuff if you want to. You can use it with something else. Maybe if you're in like a private PKI and you only care about batch signing, then you don't actually want to serve the log at all, in which case none of this sort of the yellow box matters to you at all. But as part of it, like helping understand how the system works, it seems useful to like talk about it. And then we need to actually like split apart the document. I started some discussion on the list in the GitHub, which I guess we'll sort out with the new GitHub working mode. And I guess the plan is, folks who have opinions on which should go in which, please go holler, and then someone will go do the work of splitting them up so there's concrete text for the working group to consider. I suspect if no one else volunteers, the authors will jump on that grenade, but don't let me stop you. Yeah. All right, and then next topic, I'll try to be a little brief because I made way too many slides as usual, is sort of Acme and TLS integrations, which is also mentioned in our charter somewhere. The MTC draft is a little interesting in that for a single issuance event, it produces not one, but two certificates. There's sort of standalone certificate is the one you sort of expect, and then the landmark certificate is this optional weird one that needs to somehow get into from the CAs to the servers. And so protocols like Acme will need some way to like smush it in. And this has some interesting properties. The landmark cert isn't available until a delay, even though it's part of the same issuance event. But we don't want to like delay the whole order processing, otherwise we'll delay the main certificate, and we want the main certificate to come in immediately, so the standalone certificate. And we also need to attach whatever metadata ends up being needed to help the server decide, help whoever's presenting the certificate decide which one to use. The draft has sort of an initial proposal buried in a section somewhere, and forwarded some stuff to the Acme list to go discuss there. And so I think there's like a thread on each list that folks can go from. Speaking of certificate selection, the other funny thing about landmark certs is they are not usable by all relying parties. So somehow the relying party state needs to get communicated to the the server or whoever is serving the certificate, so you can select which one. And this needs to happen robustly. The relying party might have different state of CA. You might have a CA be temporarily unavailable. It would be really bad if, like, when one CA cannot be accessible, suddenly this optimization breaks for all CAs. We don't really want to have those kinds of things in a widely distributed system. So you can kind of model this. Fortunately, there's some work in the TLS working group that fits this exactly, not entirely a coincidence. You can model a landmark as kind of a funny trust anchor, which matches just this little subset of certificates. The IDs we have over in TLS are based on OIDs, so you can just append a number. This is also not a coincidence. And then, yeah, that ends up just working. There's a change we can make that was actually originally in the plan, but we took it out of the trust anchor ideas draft because it was a little hard to motivate until this work got off the ground, which is to encode in the system the fact that if the client knows this landmark, it also knows all the previous ones. There's a typo in the slides. I should also have a .399 in there. Start a discussion of the TLS list, and also there's a pointer to it over on the points list. So go forth and have fun. And stuff that happens in this working group, we've got log generations. I think Joe started a thread about this recently. So the current design roughly looks like one CA instance is one up to key rotation, cosigner key, and also one issuance log. And in log generations, the idea is that we switch it so that you can have an issuance logs first. And why do this? For Merkle tree cert deployment that uses cosigners, we have a lot of new failure modes that we have to go deal with. A MCCCA signature commits to the state of the log, and then those cosigners will take those commitments and lock onto them and not let the CA move backwards from them. But the CA might accidentally make a bad commitment because it had a bit flip or restarted its database and something went wrong. It might commit to two versions of some checkpoint, and then some cosigners are locked onto one branch and some cosigners are locked onto the other branch. It might commit to an impossible checkpoint where preimages are not known, and then it really, really is sad. And all of these failures break the assumptions behind transparency that there is a sort of globally consistent view of the log. So it is kind of by design that the cosigners lock the CA out of doing it. But when that happens, we need to also think about what's the impact to sort of the broader PKI. And generally, when in an incident, like when you have an incident in a PKI, if a CA instance has done something irreparably broken, you need to stop trusting that CA instance and move on to another. If it was just an issue within one particular piece of infrastructure and you still trust the CA operator, maybe it's a different CA instance for the same operator. If you no longer trust the operator, maybe it's a different operator. Standard CA stuff. And then whatever changes you make, that needs to reconfigure in the relying parties. But sort of by construction, any relying parties that haven't gotten the update are not going to take the changed behavior. And services often need to serve both the old and the new ones. If the old ones only trust the old CA instance, you have to do something interesting. In X509 today, the old CA, when it goes wrong, is still functional. Like, it can still call the sign function on its key. New relying parties might not trust it, but it is still able to generate signatures to make old relying parties happy if that is a thing you need to do. With these new failure modes, the CA is stuck and may be unable to issue because it cannot get cosigned sufficiently to make the old relying parties happy. And now the services that need to serve both old and new ones are very, very sad. So how do we fix this? Well, in general, what you need to do when you recover from an incident in PKI is you want to get the up-to-date relying parties to be servable and also secure. So we need to update them past whatever broken state they're in. And the out-of-date relying parties, I mean, ideally we'd also keep them secure, but if we absolutely can't, the one thing that we need to make sure is that they can still be served. And right now we've broken that. So how do we fix this? Well, let's give the CAs a way mechanically to move on from their broken logs. Instead of saying a CA is one log, it's a sequence of numbered logs with a single shared cosigner. So before, the issuer field of the certificate identified a single log because that's what a CA was, and the serial number identified an index within that log. And now instead, the issuer identifies a sequence of logs, and then the serial number now needs to tell you both what log it's in and what entry is in. You can just sort of encode it with a tuple in your favorite encoding. And so that lets the CA recover, but now we need to go back and make sure our transparency goals are still satisfied. And in particular, we need to ensure that whatever log generations the relying parties accept, the monitors will still see it. And sort of a priori, that is a little difficult because the CA now might just go mint a new generation for every single certificate. And now this defeats the entire purpose of all of these trees, and we lose all of the like efficiency thing, the efficiency gains on the monitoring side that tree give you. But this seems to be solvable. We have sort of a range of options from like, we can kind of really trust the cosigners and just say, okay, the RPs will accept all the generations, and we're just going to assume that like a quorum of trusted cosigners and the monitors will like coordinate, and we trust that the cosigners are not like doing anything sketchy. We could have the RPs enforce sort of a maximum generation number. As soon as they do that, then the monitors can key on that rather than the state of the cosigners. But then, as the CAs have their incidents, then they need to update that. Older relying parties won't have this. We can have the older relying parties shut off enforcement, which is a little bit scary, but it is something that the CP ecosystem does today, so it's not totally unheard of. Or maybe we can say that like, 64 is more than enough for anyone. No CA is going to screw up 64 times in its lifetime. That's probably good enough. And then you just sort of say, dear monitors, please look at all 64 of them. I'm sorry. The good news is whatever sort of point in the spectrum we like a deployment ends up picking, it doesn't actually change the certificate wire format. This is just sort of a like local decision on like what the RP trusts and like what the sort of CA can get away with. And so the proposal is let's go spec the sort of certificate format and then leave room for deployments either afterwards or in the experiment phase to sort of iterate on the strategy, so we sort of have a better sense of how this will work. Yeah, okay. I'm also going a mile a minute, so if folks have questions, feel free to interrupt me. Otherwise, I will sort of keep babbling. There's another thread about Victor is in the thread. Q.
Sure. What happens if there are no cosigners, right? If I'm one of these relying parties who just, works with the CA exclusively.
Yeah. So if you trust the CA exclusively, then none of this matters. Like the CA, at least at a technical level, is able to reset its state whenever it feels like it. So then we sort of don't really have any new failure modes in terms of like instant recovery. The sort of like locking behavior only happens if you have an independent cosigner that is required to like keep the thing going forward. And the reason that makes incident recovery hard is that in order to recover without changing the protocol, we would have to tell the CA, okay, hold your horses for like the next week. You're not going to be able to issue certs, so we need to go talk to all the like cosigners and be like, please reset your state. We know that like the condition of you being trusted was that you weren't going to reset your state, but we're going to forgive that now this time. Please go reset it so the ecosystem doesn't melt down. And like that's a disaster. But if it's all within one party, then this moves. Hopefully that answered the question. Assume that it did. Like there's no limit in the queue. Okay, so another thing is we need someone to represent a CA. X509 sort of did not really bother defining a trust anchor format, and so everyone used a self-signed cert instead. And for better or worse, there are a lot of existing applications that do this. And if you're like a very fancy RP that's doing all sorts of stuff, you can just design a better format. Like this is ultimately application local configuration, and so it doesn't really matter. But given that there is a long tail of clients out there, like command line tools on random, machines and whatever else, that are all based around like being able to find root certs as certificates in this like one directory on their Linux system, whatever. It would be useful if we had a format for this. The draft has kind of a to-do. We should go do something about it. At minimum, we should probably make sure that there's some format that satisfies a non-transparency enforcing standalone certificate only relying party. Because like the sort of analogous relying parties today are generally not enforcing CT, and like they probably do not have like yet some pipe to like pick up like to-date revocation information or whatever else they're doing. And we need to encode. This is a Merkle tree start CA. Please don't do the other thing. Information for the cosigner, signature algorithm, and possibly some bounds on the like generation number and entry index, possibly. So broadly, we have kind of two directions we could go here. We could leave the SPKIs as is and stick the cosigner keys in there, and then stick anything else in kind of like a critical extension. This means that we have this one extension on the side, which changes the kind of signatures the SPKI makes, which is a little weird, but maybe okay. And it does assume that relying parties use trust anchor extensions, which is mostly fine. But because X509 never really defined a trust anchor format, like things vary wildly on whether you believe that the self-signed cert is a like dummy container for just the name and the key, or whether it's like a whole cert in its own right. The other direction we could go is we can say, okay, well, because of the funny signature algorithm, this means we have a funny key. And what is a key? Well, it's the information about a cosigner. So we've got like all this stuff, and we just jam it in the SPKI under a new type. This is, I guess, this sort of fits the like new signature algorithm model, but it means you've got this like 2-level SPKI where the SPKI's body actually contains another SPKI, which is a little bit odd. And I guess we might need to define a similar 2-level PKCS8 format. I'm not sure. I don't have much of a horse in this race, so I guess folks who have opinions should make them known. Yeah, all right. And then looking further ahead, there's an issue in the tracker from before adoption that we should probably be a little bit more opinionated about our ID allocation. Right now, we're just like, yeah, all these things get different IDs. If you're a CA, you should pick like 7 or yours. I think only 2. That was mostly because at the time we were like, we're not quite sure what the structure of things are. Log generations will change this a bunch, but as we sort of figure out what the structure is, I think we should be more opinionated and either like prescribe an allocation or like strongly recommend an allocation method, just so it's a lot easier for folks to set these things up. There's a whole lot more to say about how to actually transition to PQ. For specifically sort of the browser world, there's this document here that isn't like directly related to Merkle tree certs, but since I imagine a lot of folks here are like interested in doing a PQ transition, I thought I would mention it here. And kind of like future thing that isn't like blocking sort of our minimum deployment. It would be nice to have some kind of negotiations for cosigners so that when you have to use the standalone certs, the servers don't have to send all the co-signatures and waste a bunch of bytes. This could be useful to help the analog of what will become the analog of the CT ecosystem today evolve a bit. Every CT enforcing client today has to show up enforcement if it doesn't get updates in 10 weeks, which works because there aren't a whole lot of them, and we can all coordinate on like this is how we're going to evolve the ecosystem. But we have to do that because otherwise we cannot cycle logs in and out very well. I hope MTCs will make some of the cycling less dramatic, but given that we are talking about like which services are trusted, that will always like need to happen. And so having some release valve for like you can collect extra co-signatures and not pay for them would be very useful. And I got to fill my plant pun quota, so here's a plant pun for you. Any questions?
I think that plant pun might have been too encrypted for most people. Well, apparently you were very clear.
All right, great. That never happens.
Victor.
Right.
taking it
I just want to
easy.
get a better sense of the immediate priorities. So you laid out priorities on various time scales, but what really should be happening now, in your view?
I think probably roughly the order of what was. Let me go back to the table of contents so I remember what the order I put in there was. I need to go back a bunch. I think this is probably rough. So we need to get things going on the architecture document just because that's like the thing we put in the charter. I think getting everyone on the same page with log generations is probably the next big thing because that sort of changes structurally what a CA is. I think at that point it should be pretty easy to represent a CA, and probably also fixing the ID allocation stuff. And then the Acme TLS connections can probably sort of happen orthogonally. Yeah, so I guess maybe move Acme TLS to the end of the list. Otherwise, that is probably the order in which to do things. And I think at the end of that, unless there's other exciting things, this seems to be what to do.
Okay, people seem to be happy with that. The queue's empty, so I guess we're ready for the next presentation.
So Tom, click on your own little document thing to take control back from David Benjamin. And then you can close the briefing. Or, yeah, I don't know, however that worked. I'm too tired for this. We got
Yeah.
Deidre in the queue. Why is Deidre in the queue?
Oh, wait. Monitoring.
Go.
Do we
Brennan.
need, Deirdre Connolly,
Might not be on the wrong thing. Let's go one way away from it.
can you hear me?
We can hear you.
Yep.
Good. We weren't sure. Do we need to start whipping up some documents for TLS and LAMPs to encode to the using of any of these types of Merkle tree certs, or all? I know there are some, prototypes working in certain places, but I feel like we'll need to plug them into TLS in some fashion, and we need to, this is in lamps, I'm sorry, this is plants, but it feels like there will eventually need to be a lamps document as well. Yes?
I don't know exactly how change control there works, on what pieces of lamps we can sort of plug into and whatnot. Russ probably has a better idea of that.
Well, I'd like to hear David's answer.
Good point.
Sorry, I wasn't sure whether this was a question that I was supposed to answer, or the chair was supposed to answer. So I was like, I'll go. I
It
guess
just seems like while we're
Yeah.
prototyping and iterating, there do seem to be points in these other areas that we eventually need to inject into. And it might just
Yeah.
literally be, I support Merkle tree certs, here's the code point in TLS, or vice versa in lamps. So I just wanted to flag that as maybe we should just start. Do
yeah.
we need to?
Well, I guess that was sort of why I started those threads already. I think I guess I didn't start a lamps one. I figured. I mean, Russ, you should definitely tell me otherwise if you think this is not the right way to go about it. But I figured that the X509 connections are sort of okay, we'll define a STIGALG and stick it in there. So probably that. I assume that would stay in this working group, but we would I guess go tell lamps, hi, we're doing this. Tell us if you think this is a horrible encoding, rather
Okay.
than a separate document. For the TLS stuff, the trust checker ID stuff sort of fits this already pretty nicely. I think the extension is not it's not Merkle tree specific. It's just sort of much clearer why it's useful. And so my plan was to get that put back into the existing TLS document. On the Acme side, I think there's some, we need to catch up on that discussion. There's some discussion going on now. I figure naively that if it turns out to be a very simple use this existing feature this way, maybe send this HTTP header, then probably we can just put it in here, and if it's something bigger, then split it over there, depending on whether or not the Acme folks think it's also reasonable.
Okay. That's why the flag, if we realize we can't, trust anchor IDs might be insufficient to negotiate, yes, I support Merkle tree certs that trust MLDSA standalone, or whatever. It smells to me that we might need to serve up new documents that touch TLS to communicate that sort of stuff on the connection level.
Yeah,
Not the
I don't think
level.
so. We shouldn't need to negotiate different flavors of Merkle tree certs, because the negotiating by algorithm is kind of while TLS does have a way to negotiate by cert signature algorithm, it is basically never used because it's kind of insufficient. It's knowing that you support this ECDSA CA, knowing that your X509 stack is able to verify ECDSA signatures does not tell you that you support this ECDSA or this MLDSA CA. And conversely, once you know that you support this CA, you could infer that you could support the algorithm that CA needs. So it's kind of necessary and sufficient to get to which CA, and then that was sort of the problem we were trying to solve.
Okay, then we might be fine for the indefinite foreseeable future.
That was the intention, but
So I think what we need to do is, when the documents are getting close to working group last call, we just let the other lists that are affected know so they can weigh in on the last call. Okay. Brendan, why don't you go now?
Okay, can you hear me okay?
Perfect.
Okay, well, my name is Brendan, and I'm going to talk about server monitoring. And I think to frame this topic for me, it helps to think about what is the security guarantee that we want Merkle tree certificates as a whole to provide. And I think that at a high level, what we want is for browsers to know that they're not accepting misissued certificates. But of course, a browser doesn't know on their own whether or not a certificate is misissued. So what browsers do when they interact with a Merkle tree certificate is really they're asking, how do I know that the certificate is published somewhere? And the draft describes sort of proof structures and information that is provided to browsers to convince them that certificates are actually published. And that's good, but it doesn't totally get you what you want. So there's a second step as well, which is where a site operator comes online and goes to wherever the certificates are published and asks, hey, what certificates exist for my website? And they can then go through all of the certificates and they can check if anything was issued without their knowledge or without their permission. And if they find something, they can be mad about it or try to revoke it or something like that. Now, unlike the browser portion where we're proving the certificate is published, this part is not actually specified in the draft, and the plan is basically to leave it for future work. That said, even though it's not being specified right now, the security of the whole system still depends on both of these parts equally. And that's because you can attack the browser side and you can try and convince a browser that a certificate is published when it really isn't. Or you can attack the site operator side and try to prevent a site operator from learning about a malicious certificate. But both of those are equally valid and they both have the same outcome, which is that you get a certificate that the site operator doesn't know about. And so it makes sense to ask, why are both of these different portions of the system secure? And so starting with the browser portion, why is the browser portion secure? Well, it's secure because when we give the browser a certificate, we also give it this inclusion proof and a transparency log. Well, okay, how do we know that I'm showing you the same transparency log as everyone else? Well, because the root hash is cosigned. Why is that cosigner trustworthy? From the browser's perspective, the cosigner is trustworthy because its public key is like hard-coded in the source code. And so that's a pretty compelling reason to say that something is trustworthy. But essentially what we have here is collusion security. So this is secure as long as the transparency log and the cosigners don't collude to try and trick the browser into thinking that something's published when it actually isn't. And so that's pretty straightforward. And then moving on to the site operator portion, we can also ask why this is secure. And the answer obviously depends on how we intend to fill in this to be determined portion of the system. In CT originally, the idea was always that site operators would just download the whole log and they would filter out the things that were relevant to them and look through all of that. We know now that that is way too inefficient, both for the site operator and for the transparency log. So site operators are just not going to download that much data. But also the transparency log just doesn't have enough bandwidth for a significant portion of site operators to download all of that data from them. They just don't have that much bandwidth. So, okay, so what if instead of that, we have some kind of service, like a third-party monitor that downloads the log for us and a bunch of other site operators, and it just emails us if it sees something related to our website. And this is, in practice, how CT actually works today, where basically everyone uses a monitoring service. And the security of this basically just comes from trusting the monitor to be honest and to provide their service the way they say they're going to do it. And so given that, if we take a step back and ask, if this is our system, what's the security of our whole system? This is the answer that we get. So if we say that a successful attack is getting a misissued certificate without the site operator knowing, what has to happen is that a certificate authority has to misbehave to misissue that certificate. And then either a quorum of cosigners have to misbehave and sign some kind of fork to keep that certificate secret, or our third-party monitor has to misbehave and just not tell us about that certificate. And that's kind of really deeply unsatisfying because, you have this quorum of cosigners that they are vetted by the browser. If they misbehave and sign a fork, you can show the signature of that and you can prove they misbehaved. That whole kind of system is undercut by this monitor where none of that is really true. So the monitor is not vetted by the browser in any real sense. It's also really hard to prove that they misbehaved. Like if you say like, oh, the monitor didn't send me an email about this certificate, like how do you prove that they didn't send an email? That's like very squishy. And so that's kind of not great. Something that we could do to potentially make that better is we could replace our third-party monitor and we could do something like a verifiable index. And the verifiable index could have cosigners as well. That is better for sure, but from a security perspective, really what you've done there is you've replaced your third-party monitor with this verifiable index system. So really what you still have is this kind of auxiliary system that is outside of the web PKI. It is outside of any kind of formal root program, and it is directly undercutting the security of the web PKI. And so all of the work that browsers put into designing their transparency policy, or all of the work they put into finding trustworthy cosigners, kind of doesn't matter if this verifiable index system is not also holding up its end of the deal. And that really sucks. However, there is one kind of loophole here that we can work to potentially make this better. And that is, if we know that the cosigners are the exact same in both cases, then we can kind of simplify. So if we know that the same cosigners that signed the CA logs the browser sees also signed the verifiable index that the site operator uses, then it kind of doesn't matter whether those cosigners misbehave when they sign the CA log or when they sign the verifiable index. You know, it's the same cosigners in either case. And so this kind of fake math expression, we can simplify it. And we can say that the security of our whole system just depends on, you know, the CA not misbehaving or this quorum of well-known vetted cosigners not misbehaving. And I would argue that this is a lot more intuitive, and it's also probably closer to the security model that we actually want for our system. And so how do we actually do that in practice? Because, I mean, the problem there is that we're saying that the server, when it's doing monitoring, needs to be able to verify cosignatures in the exact same way as the browsers it cares about. However, a server is not a browser. So the server doesn't have the benefit of having like the CAs and the cosigners and the cosigner policy being kind of pushed down in its source code for free. So, you know, in general, with that kind of problem, the best you could do is have the site operator basically track the development of every browser they care about. So they would have to like go find documentation or source code and try to manually replicate how the browser is configured and how the browser verifies cosignatures. That's obviously really brittle. It introduces a lot of manual labor and also like a lot of room for mistakes, especially when you consider being able to track how these policies evolve over time. That could be a big source of issues. So, you know, we could potentially add some kind of like explicit protocol mechanism that directly solves this by having like browsers advertise their cosigner policy or like confirm it in some way to servers, so that servers, when they connect to a browser, actually know what the cosigner policy is. That is an idea, but it's also probably pretty brittle and not really going to work. So the best option actually is probably this last one, which is where we add a new log entry type to the CA logs. And that log entry type contains the verifiable index root hashes that we want to convey to the server and that we want cosigned by the same cosigners. And the reason that this works is because, you know, every certificate that the server has contains this kind of inclusion proof to a tree head. And if the server advertises a certificate to a browser and the browser accepts it, that tells the server that that tree head was like cosigned or authenticated correctly according to whatever the browser's policies are. And if we know that that tree head is cosigned correctly, then that also means that our special log entries with our verifiable index root hashes are also cosigned correctly. And so that's a pretty nice clean solution. The only real remaining problem that you have there is that when the server is doing monitoring, it needs some way to actually find these log entries so it can get those root hashes, right? And the log could eventually be very large, it could have a lot in it. And so we want to be able to do this efficiently. So not just like download the whole log And we also don't want to reintroduce any new trusted parties that are going to work their way back into our security model, like the third-party monitor kind of did. So the easiest way to do that, I think, is probably just to like add a counter to each log entry that contains the total number of these special accumulated type log entries that have been sequenced so far. So these accumulated log entries contain the verifiable index root hashes, and then we have this counter in every log entry that tells us how many of these have been added so far. And what that lets you do is it lets you do a kind of a verifiable search through the log entries for either the most recent one of these log entries or a specific one. If you want to look at a specific one, you can do that instead. So whenever the server wants to do its monitoring, it does this search for the most recent accumulated type log entry. It looks in that log entry, it gets the verifiable index root hashes, and then it's good to go actually talk to the verifiable index and look up the certificates that are related to it. And I opened a PR for this that is open and ready for review. And that's all I got. Thank you. Filippo.
Filippo, sort of for the notes. I like it. I need to flip it in my head a bit before I can decide if the transparency part makes sense, but you thought about it, and I think I trust that. The only thing, this requires CAs to operate their own verifiable index, right? Because we're not defining a way for the CA to accept without making there is no way for third parties to add these verifiable index 3 heads to the CA's log. Is that correct?
So the CA has to cooperate in adding those log entries with the root hashes, but I don't see why there's a reason why the CA has to run the verifiable index. So you could have the third party run the verifiable index and just submit those tree heads to the CA to be logged.
But who is taking responsibility for the correct construction of the index there?
So basically the CA's role here is just in co-signing, so just in making sure that everybody has the same view of the verifiable index. In terms of making sure the verifiable index is constructed correctly, that would be done by basically anonymous people that are crawling the CA log and reconstructing the verifiable index.
Okay, so the entry would have like an identity of the verifiable index operator. Okay, that's the part I was missing. And I assume the CA will want to have some level of rate limiting for that, like not get spammed and so on, right?
Yeah.
And don't the accumulated counters though need to be per verifiable index operator?
I don't think so. I think that I would just batch all of the different verifiable indexes together into one log entry and just add one log entry with all of them. And so you lose a little bit of granularity, but that's kind of the cost.
Okay. Yeah, simply because there's a chance that if it's not the CA, a verifiable index operator will just, mess up or lie, and we will want to not use that one, and at the same time still be able to find the other ones.
Right.
Cool. Yes. Thank you.
Thank you.
Hey, Luke Valenta. Yeah, thanks, Brendan, for the talk. So I think maybe you just answered this question, but so the verifiable index has to cover all CA issuance logs that could potentially be covered by, or that could potentially be trusted by clients. Is that right?
I have some thoughts on that, but I don't think that I don't think that this locks us into any particular decision there. So I think what you're asking is, does the verifiable index need to cover all CAs or just one CA? And my perspective on that is that I think probably the best decision in the end would be to have the verifiable index cover all CAs, but this PR doesn't lock us into that decision. We could do it with just one CA.
Cool, thanks.
Yes, I'm hearing a lot about servers and browsers and things. Where do client certificates fit into any of this? I don't even know if it's a question for you or for David or for whom, but is there a place in Merkle tree certificates and transparency for client certificates?
That's a really good question that I am surprised by how surprised I am by. I don't see why this would not work for client certificates, but I don't want to promise that. Maybe David can say.
I guess I'm in the queue. Yeah, I think like mechanically, client cert would work here. I think the main, like, there's a lot of different client cert PKIs with different, requirements, and I think probably some of the questions would be around like, I guess like, what are you trying to get out of Merkle tree certs? Are you trying to get like batch signing just, or are you also trying to get like some kind of transparency story? And if you're trying to get a transparency story, are the identifiers in your client cert secret or not? Because for sort of like CP style transparency, we can play on easy and assume that all the identifiers are public. If they contain people's email addresses, maybe not so much. I guess the sort of the like various points in between that space that Filippo will be talking about. But I don't know if that answered your question.
That's a big part of it. But if somebody does want to, leverage this stuff in order to get to PQ without monstrous certificate chains on either side,
Okay.
do they fit into this story in some manner? Maybe without transparency, don't know. What's the? I guess this goes in the architecture doc. There should be some thought there about client certificates.
Okay, so I guess so not. I don't want to steal your time slot, Brendan.
Right.
But so because like I guess this is like not directly related to transparency, but if you want the size optimization, then like I think that probably does not require that you like publish the log or do anything if you just like have some way to get the hashes down. So that's probably doable, but I'm not gonna like design things on the fly. Yeah. What was my question? The question. Yeah, okay. So I guess it looks like the shape of this thing, like, I imagine that figuring out the right sort of like authenticated index type thing will be like a whole work in itself. And so I guess the question is like what is the minimum thing we need to like stick in here to make this later work possible, without sort of committing us to too many things we're not sure of yet. One thing I'm slightly unclear on is like, so you've got this like accumulated type enum, but I imagine that especially if you're imagining that different people will operate different v-indexes, that it's not so much a type, but like a type is a small set of code points, but there might be like multiple v-indexes of one type. We might need to like update the indexing function if we like find a bug in the previous one, or if someone invents a new way to stick DNS names in certs or whatever else you want. So I guess I'm not like, how do you see those sorts of changes interacting with the like accumulator type thing and also this like all-in-one count?
I think that like my default solution in all of these cases where like we have multiple v indexes or we have multiple indexes of different types, I think my answer would be we just have like the accumulated log entry type. We just have it break down everything so we just have like one big log entry that contains a list of everything. And then we like maybe have an identifier of whose log it is. We say what kind of log it is, and we just have this big list. And I don't right now see a reason to break that log entry up across different types of log entries.
I guess in that case, why do we need the accumulated type in there? Like the sort of dichotomy between there being lots of different types, but then one shared counter is the thing that's like very much confusing me about this, because I guess you'll be binary searching to find the next one or the previous one, and then you'll have to like bouncing back and forth or bouncing back to the previous one if like you didn't find the right one, unless they're all sort of batched together. But then the CA might not be able to batch them together if like one of them's being really slow. So I guess sort of those dynamics are very unclear to me.
Right. The purpose of the accumulated log entry type is just to get that counter. which makes it efficient to find specific ones. So you have this big log with a bunch of different things in it, maybe a bunch of certificates. And so that counter just makes it easy for someone to go in and verifiably find a specific accumulated log entry type. And I think the rule would be within a specific accumulated log entry type, you would want to keep it relatively small, understanding that people are going to have to pull that out and like pick whatever they want out of it. You know, you wouldn't unnecessarily split it up across different log entries. But yeah, the purpose of the accumulated log entry type is solely that we can have that counter, we can get it in the protocol now, and then we can figure out later what do we actually want to put in that space.
I guess because you need to, like, if you're going to define a counter and say it counts something that we haven't even defined yet. I mean, we could just have the counter and be like, it's going to be 0, we'll make it non-zero later. Please ignore this for now. It's kind of weird. Is it possible to just stick the like in the counters in like we'll just say every 100 or every like 256 entries, please go put one of these in there, and then you can just sort of jump over to find that one. Or does that end up being too goofy?
I think that does introduce a lot of problems because you don't know how fast the log is going to grow.
But you as the CA get to control how fast. Like you can just be like, oh, I've gotten to 2.6. It's time for me to
maybe
flush out a like summer. Oh yeah, probably. Yeah, we can do this.
Maybe
offline,
we're
sorry.
getting a little bit too in the weeds here, and approaching the point where people are starting to pull out whiteboards to keep following what you guys are talking about. So let's maybe park this for now and continue this on list or on the GitHub pull request that's linked on the slide in front of us, and move on to, I think, John Gray, who's in the queue.
Yeah, well, I was just wanting, can you hear me? Hopefully. Yeah, I was just going to say I wanted to respond quickly just to what Victor was saying, because I've had the same kind of trying to wrap my mind around how these things could be perhaps used, you know, in client certificate use cases or, you know, private PKI. So I just posted email on the list, like, I don't know, an hour ago. So Victor, that might be something that'd be interesting to discuss and, you know, talk about. Maybe it ends up being something that's put into an architecture document if there's something that can work, because I'm not sure yet if all this complexity or whatever is worth the effort. I don't think we would need monitors or logs to do it, but there might be a way to do it that's going to get some efficiency, especially with larger PQ algorithms. But I think that's something that might go into an architecture document. So just wanted to mention that.
Bas indicates Bas Westerman in chat also indicated he's very interested in working on this.
Yeah, so great. So let's talk on the list then.
Okay, then Filippo is in the queue.
Filippo for the notes. Feel free to tell me, this is handled, just read the PR, but if the CA is adversarial, which I think it is here, can't the CA not collaborate to publish those verifiable index 3 heads and hide those from the servers?
I mean, the CA cannot accept those requests to log the heads, but all that results in is like an authenticated negative. So the server, whenever it tries to do monitoring, it would be able to authenticate a negative result that there are no recent tree heads that it can look at.
And I assume that would, you know, lead to the conversation and so on. And if it chooses winners and losers, we're not really worried because either the indexes are correct or it's the same thing as not accepting any, to only accept like bad indexes. Yeah. Right?
Yeah.
Okay, cool. Thank you.
On the private PKI thing, lots of people are chiming in that they're very interested in discussing this issue further. So we'll see probably some activity on the list on that. At least I hope so. Thank you, Brandon, for this presentation. And since the queue is empty, I should be moving over to the next deck, which will be for Luke Valenta. And I'll
Okay.
press the button. I have
all right,
pressed
great.
the button. Take
Yeah,
it
looks
away.
like I have. All right, sounds good. Thanks, Tom. So Luke Valenta. So we were really excited to get some running code with Merkle Tree Certs. So we started, I guess, working last year between Chrome and Cloudflare to get an experimental deployment up. And what I have here today is just some early results from that experiment. And let's get to it. Oops, too fast. Okay. So we wanted to evaluate just make sure Merkle Tree Certs was going to be feasible in a real deployment, and also to check that the performance actually matched what we kind of expected. So in the experiment setup, Cloudflare is the server. Currently have it enabled for 1,000 Cloudflare proxy domains. Cloudflare is also running the MTC CA in sort of this funny bootstrap mode. We wrote a blog post about it with some more details. But since Cloudflare is not a real CA, we issue MTCs that are backed by a existing traditional cert chain signed by a browser trusted CA. This kind of being tied to this bootstrap mode restricts us to only experimenting with classical signature chains, because that's what we have in the web PKI today. And we're also using this like 7-day cert validity for the MTC claim. So a bootstrap cert might cover multiple MTCs, I guess, that are split into 7-day chunks. We're also just looking at landmark MTCs, the standalone, I guess, in terms of like performance and stuff, it should be closer to traditional X509 plus CT chains. But yeah, so we wanted to look at landmarks where the real optimization from MTCs comes in. In terms of experimental parameters, we're issuing landmarks every hour from the CA. And then in our experiment, the largest proof sizes we get are about 512 bytes. In a real deployment at web scale, this would be, I don't know, 700 or 800 bytes. So we're a little bit lower than you'd expect and that we'd expect in real life. Chrome is running the TLS client, currently enabled for 50% of Chrome beta. And it also runs the service that that fetches and validates the landmarks from the CA. And the client state for storing all these landmarks is about 10 kilobytes with the current parameters. So all of these parameters can be tweaked a bit to get the client state to something you're happy with, along with I don't know, all the other parameters in the system. And then here's a screenshot. This is from Chrome, the certificate viewer of a real MTC being served. You can see the kind of funny certificate issuer there, which is the OID we're using for the experiment. And this identifies the CA that we're using for the experiment as well. And then in the signature value field, you can see this encoding of the inclusion proof, and which is instead of a signature. So we looked at the performance. So this is the this measurement we have here is from on Cloudflare servers, the total time it took us from when the handshake was initiated to when the connection was passed on to the I guess after the TLS handshake is completed and the connection is passed on to the next service in the stack. So we found that at the median, the MTC group was about 9% faster than the control group. And this is with classical signatures. So once you drop in post-quantum signatures, we expect the performance gap to be even bigger. We think, yeah, so MTCs don't grow as quickly with post-quantum signatures as traditional cert chains do. So this is kind of what we expected, but great to see it in the early results from the experiment as well. The other question we asked was, can clients keep up with the landmarks? Are they able to get these frequent updates to make sure they have up-to-date landmarks so that they can actually be served CAs, MTCs that they trust? And so this is just showing from some internal dashboard after we enabled MTCs for a whole bunch of domains, how quickly clients were able to start using those MTCs. Pretty quickly, most clients were able to update within a few hours to get the recently issued MTCs. And then the steady state in the experiment was about like 1% of clients were stale. And we expect this to be kind of an upper bound just due to quirks of how the experiment's deployed. We think it'll be a little lower for a real deployment. So I think the most important thing that we showed with this is that MTCs actually work. They are used to deploy or to secure real traffic today, albeit in this kind of bootstrap mode. Performance was, I guess, there's a latency improvement in the TLS handshake over using a classical signature chain. So that's, I guess, and the reason for that is just because we're sending fewer bytes over the wire over like RSA plus ECDSA cert chains, and it's generally not a problem for clients to stay up to date with the landmarks. In terms of operational experience, we've had to shake out a few bugs on both the client and server side, just mostly related to the bootstrap mode. And middle box interference is another thing we wanted to look at, and so far hasn't been a factor, mostly because this is encrypted, or the server certificate is encrypted in the TLS 1.3 handshake. So that's what we want to see. And I think I don't have any more slides, so happy to take questions.
No one else, then I will ask a question. So this middle box issue, it is true that TLS 1.3 encrypts everything after server hello, but there are also middle boxes that decrypt people's traffic. Have you got any clue how many of those sorts of corporate spyware networks this experiment would be penetrating right now?
No, I'm not sure exactly. I guess I think that's something we'll look at a little bit more later. See how many. I guess we'd see a downgrade, essentially from NTCs to just a normal handshake from the middleware. So at least server side, we don't have those metrics. We might be able to see some more from the Chrome or the client side metrics.
I guess that makes sense, that it would be a downgrade. And also, I mean, intuitively, probably there's not a lot of beta clients with inside banks, highly controlled networks. But yeah, interesting to see how this develops.
Looks like Deirdre's next.
For eviction from cache for landmarks, is it just last in, last out? Last in, first out? First in, first out. You know what I mean? The oldest one gets evicted first.
On the server side of like when we're reissuing the landmarks.
On the client side. On the browser side. You said you have 10 bytes of cache.
I see. Yeah, so this gets pushed down I guess by the browser update service. I think, yeah, I'm not sure exactly how the mechanism works, but I think they just every time there's a new landmark, they recompute the bundle and send it down to clients. So I don't know if it's just sending down 10 kilobytes every time or if it's a incremental update. Yeah, maybe David can answer definitively.
So this is kind of up to the implementer of how exactly they want to manage the pushing and management of landmarks on the client. And in the case of Chrome, they basically were like, the whole browser gets a fresh view of landmarks and gets shipped with it every time you apply a browser update, which has its own diffing and smart data update stuff.
I actually don't remember offhand, like how I actually don't know offhand if the update service, like I assume it does diffing things. It does diff very nicely in that, like, if you were like here and then you move forward an hour, all the ones in the middle are the same. So if we're not diffing, we really should be diffing. In terms of like when things fall off, the sort of window of landmarks that you want should be like they should be sized so that all unexpired certificates are covered. And so like the parameters we tune are like you want to tune the time between landmarks and the max cert lifetime such that like the number of landmarks you want is bounded, because it is really annoying for like certificate usage if like the before the cert expires it might fall off on clients. Life is a lot easier. It can just be like client's up to date enough, it's good. By the time it's not good, you have to get a new cert anyway.
Is there anything written up with the finding that sweet spot as a client in any of these documents?
I think the document has a recommended allocation scheme, which I think you set the number of the time in between them. Although I think like that probably could be tuned a bit. So there are some like example numbers, but there's not like you should maybe use these numbers. Probably what we should actually write is like, this is the number of active landmarks you probably want to have, and then you scale everything from there. Like, and if your search lasts 45 days, 45 divided by n. If they last a year, do 1 year divided by n.
Okay. Thank you.
I see
Guilin here, from Huawei International. I just have a question about the middle of this slide. From the data you show, something like the performance is for classic signature is 9% or 10%. So does it mean this is a significant latency improvement, or maybe I missed something? But of course, I agree with you. Once PQ signature used, the gap should be bigger.
Yeah, that's right. I think you interpreted it correctly. So I guess the raw numbers here. So at the median for the MTC group, the clients that, or the TLS connections for which a MTC certificate was negotiated, the median was 105 milliseconds. And then for the control group, which still, I guess, it sends the trust anchor IDs TLS extension, but doesn't actually negotiate MTC, the median was 116 milliseconds. So we were a little faster with MTCs. And this is a nice improvement. Even if we weren't, didn't have post-quantum signatures looming, this would be something that would, I don't know, maybe justify some deployment, a performance boost like this.
Okay, thank you.
Okay, I believe we've exhausted the queue. Thank you, Luke. And let's move on to the last presentation for Filippo, who has asked permission, but where does that go to? Right.
And I got a over-constrained error, whatever that means.
I
Aha.
have pass control.
Yes, excellent. Okay, so lots of interest in MTC for private PKIs. So this is probably going to be interesting to people that care about that. So what we're going to do is look at MTC and prune it down until it's just a signature algorithm. And then we're going to look at how you can then modularly add back pieces of MTC that are useful to your PKI. So the core insight is that you can use MTC wherever you like. The thing that requires a interactive protocol with a client that can do sync and landmarks are the size benefits. For those, you need the the web PKI and TLS style setting. But if you're just doing a private PKI, as long as you can do X509 signatures with a new algorithm, you can do MTC and we're going to see how the MTC shapes down to being completely isomorphic to a signature algorithm. We could call it MTC DSA. So let's start with MTC. MTC, you have a few public keys, the CAs and the other cosigners that sign a tree head. You put your certificates into a log and you sign that tree head. Okay. Although in practice, what you actually there's this optimization, which is the sub-tree signing, where you actually obtain a signature over a smaller portion of the tree and use that signature instead of the one over the whole tree, because that makes the inclusion proof smaller. So step one of making, anyway, that might sound complicated. There are moving parts. There is stateful stuff. There is transparency stuff. So the question I got at River Crypto in chat is, okay, how do I use it for this constraint PKI that can't do all of these bells and whistles? Okay, step one, you use standalone Merkle tree certs. Forget about landmark certs for a moment. A standalone Merkle tree certificates is that bundle on the right. It's the signatures from the cosigners over the sub-tree head and the inclusion proof, the Merkle tree inclusion proof for the certificate. That thing in the box, in the yellow box on the right, is the signature. Like, you can think of that as the MTC DSA signature. So it's what goes into the signature field of a certificate. Now, first thing we can do, so let's ignore the log for now. Let's just focus on that signature part. The first thing you can do is, my PKI does not have transparency. I don't have cosigners. I only have the one signature from the issuer. So now you have the issuer signature over the sub-tree head and then the inclusion proof for the certificate. The next step is that you can actually make that sub-tree size 1. And if the sub-tree size is 1, the signature is over the leaf. So now the whole thing that's in that box on the right, which is the signature from the issuer, is the signature from the issuer. So essentially, we reduced the MTC signature to nothing else than a roundabout way to get to a single signature from the issuer on the certificate. Finally, what you can do is that you can forget there was ever a log. You don't have to implement MTC statefully. The only thing you should avoid doing is putting 2 certificates in the same place in the log. But we already had that requirement for CAs, which is the serial number uniqueness requirement. You are already supposed not to sign 2 certificates with the same serial number. So you can make a stateless MTC CA that just sign things by signing a sub3 size 1 and produces a standalone certificate of that size 1 sub3 and doesn't even log the certificate anywhere. This will work with a general enough MTC verifier. Now, yes, this is a degenerate case. The reason I wanted to go all the way down in pruning is to show that you get, if you scratch enough, you get something that's isomorphic to the current X509 PKI. Like currently, X509 PKIs have a signature from the issuer on the certificate, and you can prune MTC down all the way down to that. Now, why would you do that? Like, why go all the way down into that degenerate case? Well, you can then add pieces of MTC back up. For example, one thing you can add back is you might want to rotate the issuer key. And MTC has essentially a key rotation embedded for free because you can sign with 2 different public keys. Now, this is if you don't care about size, but maybe in your private PKI case, you don't care about size and you like the idea of sending down a certificate that is signed by 2 issuers at the same time. Then you might want to add back the log and actually have the audit log. And you might want to do that specifically because quantum computers are coming. And you get the same downgrade strategy as the one that Chrome described for the web PKI, where the signal for opting in to a downgraded classical signature scheme is to get a certificate with a classical public key in it and logging that into the PQ PKI. And for that, you need the audit log. So MTC has an audit log just ready for you there. But now that audit log, you might also want to get it co-signed by someone. For example, you are a CA operator, or you have different organization parts in your different parts in your organization, and you want your client or your other team to co-sign your PKI, so that you can sell something like, we will run your PKI for you, but you retain control because your clients will check both our signature and your signature, and you can do monitoring just like in CT. So essentially, you can do CT for private PKIs. This is all if you want. These are things you can add back. And finally, if you have a slow HSM, you could make the sub3 size not be 1 anymore. And now you sign with the HSM once every few certificates. These are all options of things you can do. So what I hope this shows is that sub3 size 1 standalone MTCs are isomorphic to X509 signatures right now. So they will work anywhere. They should work anywhere the current ones do. So we could actually make that the only PQ-PKI code path. I'm not saying we should. To be clear, this presentation is about getting a intuition for how these things are possible and how you can use pieces of MTC. Maybe we also should, so that we only have one PQ issuance code path or only one PQ verifier code path. I'm not sure about that, but at least it's a thing we could do, and it probably informs how you can do private PKIs. Thank you.
Thank you, Filippo. I think those figures were very helpful for lots of people. Is there anyone that wants to insert a comment in this last minute of the meeting? If there's any other business that we want to talk about as a group?
Thank you, everyone. I think we had a very productive first session for the plants working group.
Yeah, thanks again to everyone who presented and weighed in with comments. And we will see each other on the list then, since we're at time.
Good night.
Goodbye, everyone. Oh, and thanks, Mike, for helping with the notes.
Brilliant.